Hey guys, today we're going to be solving Leetcode question 1027, longest arithmetic sequence. This is a dynamic programming question. It's a very popular question, and if you've been struggling with this question, don't worry about it because it is not a very intuitive. The solution to this question is not very intuitive. I struggled with it as well. If you have been, it's fine. I hope I can give you an explanation that you can easily follow. So let me just explain you what the question is. We are given an array of integers and we are supposed to find the longest arithmetic sequence that we can in the array. Now the sequence can be increasing or decreasing, doesn't matter. So as you can see in 3, 6, 9, 12, the maximum length that you can find is, and I hope that everyone knows what an arithmetic sequence is. An arithmetic sequence is a sequence of numbers in which the difference between all consecutive numbers is the same. So like for 3, 6, 9, 12, the difference between consecutive integers is 3, and the total number of numbers in the sequence is 4. So the answer is 4, and it is an increasing sequence. um, if we look at this example, the longest arithmetic sequence is 20, 15, 10, 5, which is a decreasing sequence. Now, I think the question is easy to follow. What also helps um, with the solution to this question is that they've only asked for the length of the longest sequence. They're not really asked for the numbers which make that sequence. So that makes the solution a little easier. Cool. So I won't waste too much time in trying to explain how you arrive at the solution because I couldn't. I looked up the solution and I understood it, and now I'm just going to present the solution and explain it to the best of my abilities. Cool. So this is a DP problem. What we're going to, this is not a very typical dynamic programming problem in which you have a 2D table. Now, not all dynamic programming solutions are like that, but usually you would find a 2D array and which you'll build, and you'll find the result at the bottom right or the top right, or maybe a single array of which the last element is the answer. This is a different kind of dynamic programming in which there is some memorization, and you do look at previously calculated results to compute the result of the current element, which is why it is a dynamic programming solution. So what we're going to do is, if we have an array of n length, we are going to maintain another array of n length in which every element of that array is a dictionary, meaning we have a dictionary for every element in the original array, and this dictionary the difference between this contains information which indicates the difference between this current element and every previous element, plus the number of times that difference has occurred before that previous element. Now that is a lot to process. It's really not that difficult. I think it's best if I type it out on the IDE and explain to you rather than trying to verbally explain it. So let's just go with a simple example. What I mean to say is, if we have a numbers array of 3, 6, 9, 12, we will maintain a DP array of 4 elements which have their own dictionary. Okay, in which every element is a dictionary. I hope dictionary or hash map, either it's the same. Dictionary or hash map contains a key and a value, and the key is a hash value. So it's order one access time. Cool. So what we will do is, now for 3 there is no element before it. Okay, let's just assume that the dictionary element for 3 is empty. Okay, it's an empty dictionary. Please uh, please note that dictionary and hash map are the same. I am more used to, excuse me, saying dictionary because I am a Swift developer, but it's the same as a hash map in Java, so don't get confused in that. Okay, so the first element will be an empty dictionary. Okay, now We have to calculate for the second element, for 6, we have to calculate the difference of 6 with every previous element. Now there is only one previous element, which is 3. What is the difference between 6 and 3? 3. So we'll make an entry in the dictionary for 6 saying 3 comma 1. 3 is the key and 1 is the value. Now what does that mean? That means that the difference 3 has occurred once before 6, which is true, right? We've only seen 3 before it, and the difference between 6 and 3 is 3. Okay, that is what that means. Now moving on to 9. Now we have to calculate the difference of 9 with every previous element of 9. So we will calculate the difference of 9 with 3 and the difference of 9 with 6. Now the difference of 9 with 3 is 6. Okay, so we'll make an entry of 6. And how many times have we seen this difference until now? Once. So we'll say 1. Now, what is the difference between 9 and 6? It is 3, right? It is 3. So what we'll do is we'll enter 3 and 2. Yeah, this is the crux of this problem. Okay, what we did is we will we will subtract 9 from 6. We will so we'll subtract 9 from 6. 6 is that previous element that we are currently inspecting. We are inspecting all previous elements of 9, but if the current previous element is 6, we will inspect the dictionary of 6 and see how many times 3 has appeared before 6. So basically we will use the dictionary of all previous elements to construct the dictionary of the current element. What I mean to say is, when I calculate the difference of 9 and 6, I see that the difference between 9 and 6 is 3. I also see that 3 is a key in 6's dictionary. And then I see that 3 has occurred once before 6 because there is an entry of 3 to 1 in 6's dictionary. So I'll take that value 1 plus the 1 to account for the difference between 9 and 6. I hope I explained that well. That is really the crux of this problem. If you get this, you'll get the entire solution because it's not difficult after that point. If you get this point. Anyway, I think we can move on. You'll understand this as we code, but this is the core concept of this problem. Now, I will calculate the difference of 12 with all previous elements. The difference between 12 and 3 is 9. That difference has never occurred before 3, right? So basically, when you inspect the difference between 9 and 3, I also look at 3's dictionary to know how many times that difference has occurred before 3, right? And nothing has like there are no elements before 3, so it's an empty dictionary. Yeah, and that's why 3 has an empty dictionary. I hope you get that now. Why? Because there are no elements before 3, so there's nothing to calculate the difference with. Okay, so 12 minus 3 is 9. That difference is 9, and it has only occurred once, so I enter 1. Then I calculate a difference between 12 and 6. Now 6 has never seen a difference of 6 before it, right? There's no entry for 6 in 6's. There's no entry for the difference 6 in the element 6's dictionary. So again, this will be 6 1. And then finally I'll calculate the difference between 12 and 9. Now I look at 9's dictionary. 9's dictionary says that until 9, the difference 3 has occurred twice. Okay, now I take that value and I add it to update the entry in 9's dictionary. Sorry, so this will be 3. Cool. So that basically and we will be maintaining a max value throughout in the loop, and we'll keep updating that in the loop. That is more of the coding logic. Calculating the max value from this is very easy. Understanding this is more important. So now what does this TP array mean? So 3, what we can see is the difference 3 has occurred thrice before 9. Now if we are actually, please note that we are actually counting how many times we have seen this difference, right? So the final result will be that max value plus 1, because you need two numbers to make a difference, right? So if we have seen the difference three thrice, it means four numbers were used to create those three differences, right? If I say that I've seen a difference of 10, it there has to be two numbers that made that difference, 11 and 1, or 12 and 2, or 15 and 5, right? So what I basically want to say is, if the number of time that the number of values in the final sequence will be one more than the number of times we have seen that difference. Okay, now I've explained all that there is to explain with the concept of this solution. It is an order n square solution, because we'll have an outer loop which will iterate through all the elements in the array, and then we have an inner loop to iterate over all the elements before this current element, right? So it becomes order n square. I think that's enough to start coding. I'm sorry about the notification sounds that I'm getting. I should have switched off my phone. Anyway, I think we are ready to start coding. It's if you understand this concept, it's a very easy solution, right? Okay, I'll get right to it. Okay, no, let's just comment this out so that we can keep referring to this. Okay. Please note that the minimum array length is 2, so we don't have to make any empty array checks. They're basically saying that you'll at least have the minimum answer is 2, because they will if there are two numbers, they do form an arithmetic sequence, right? Like any two numbers in the world. So they're basically saying that we'll not give an empty array. We'll make sure that you have at least some sequence, and the minimum length of that sequence is 2. So I'm not putting in any empty array checks. Please note that I'm going to write verbose code. There is a lot of redundant code that I could avoid, but just for the sake of clarity, some I'm going to introduce some extra variables that I don't really need, basically, is what I'm trying to say. Okay. The length of the array, hash. I'm sorry, I've been saying hash map, but what I mean to say is, I'm sorry that I've been saying dictionary, but it's the same as a hash map in Java. Okay, so it's an integer to integer hash map, and this will be an array. We'll call this the DP array, creating a new instance for this of the same length as the original array. Okay, this DP is basically this array, this entire array. Okay, moving on. This is the max value, is the final answer. Okay, and this is what we'll also return. So as I said, it will be max value plus 1. Why have I initialized it as 1? Because that is the minimum number of times that I'll see a difference. Even if there are only two numbers, which is the minimum array length, I will see that difference once, right? And the final answer is the number of numbers that form that difference, which is 2, because you need two numbers to make a difference. Okay, let's move on. This is so iterating over all numbers, say int I equal to 0. I'm sorry if I'm coding too slow. Java is not my first language. Okay, iterating over all numbers. Let's pull out the current element that we are inspecting, semicolon. Now let's pull out the dictionary. Actually, let's instantiate the hash map for this current element, because we are going to construct the difference dictionary for this current element. It's not there. So I'm instantiating a new hash map for this current element. And please note that I'm using dictionary and hash map interchangeably. It's the same thing. It's a key value pair data structure. Now, okay, just I'm just going to assign this to a variable current map just for clarity. Okay, so current map is the empty hash map of the current element that we are going to construct now. Now I'm going to iterate over all the elements before the current element. So for all j before I, I'm sorry if I've messed up the indentation. Okay. Okay, so what is the difference between the current element? Please note that it's this solution will also account for decreasing sequences, because that difference will be stored as a negative number, but it's only an entry in the dictionary, so it doesn't matter. This will cover increasing and decreasing sequences. Current element minus AFJ. Let's pull out the hash map of the previous element that we are currently inspecting, right? Because we do need that. Okay, this is previous map is the dictionary of the current previous element that we are inspecting. Okay, now let's say this is the new value that we are going to put in our current map. Okay, now the previous map could have seen the difference that we are currently inspecting. Okay, so if I'm the previous element, I have been reached by some current element by a difference. It is possible that I have seen the difference between me and the current element before me, and it is also possible that I have never seen it before. Okay, so if I have seen it before, I'll just pull out that value. If I have not seen that before, I'll just initialize that as 0 and add 1 to it. Please note that I'm adding this +1 to account for the difference between the current element and this previous element that I have arrived at. Because of that difference, I'm just accounting for that difference. That's the +1 that I'm doing here. Okay, moving on. We have to update our current map. Yeah, we have to put this current difference that we found and the new value. Okay, it is possible that this is the first time we are seeing this difference. It is also possible that we just added on to a difference that we saw before. And what we are doing, so you should, what we can realize at this point is by seeing how many times a difference has occurred, how many times the same difference has occurred earlier, we're actually calculating the longest arithmetic sequence, because we are trying to find the maximum number of times that we have seen a difference, right? Cool. And arithmetic and an arithmetic sequence is a sequence of same differences. We are continuously looking at how many times we have found this difference earlier. Yeah, we have to, because current map would be a copy, so I have to assign it back. Please note that this can be done in a more concise way. I'm only writing it this way so that it's more verbose and it's easier to understand. And finally, we'll update our max value. So we'll update this max value continuously. So this is where I said that it doesn't matter which numbers are forming the sequence. It only matters how many times we have seen this difference and how many numbers are forming the longest arithmetic sequence. The which numbers are forming it doesn't matter, which makes this problem and solution easier. That's it. That's really it. Let's see if it works. As you can see, it's an order n square solution. Oh, I'm sorry. Didn't put that semicolon in. As I was saying, this is an order n square. Oh god, I'm so sorry for missing these semicolons. Okay, the base case passed. What I was saying is this is an order n square solution because you can see there are two for loops over the same input array. Let's submit this. Okay, that's it. I hope I did a decent job in explaining the solution to this problem. I did find this challenging, which when I first solved it, which is why I wanted to make a video about this solution. Uh, I hope you're staying safe. Take care and happy coding. Have a good night, good day wherever you are. See you. Bye.